Hello and very good evening to all of you. Welcome to Resultant JE YouTube channel. And I am Vikas Sir. Welcome you all to this practice session on the IC Engine subject for the RRB JE 2024 examination. Series is Game Changer series, and where we are definitely helping you out with the practice of the questions for RRB JE or any other examination where technical subjects are being asked. We can say those students who are from mechanical background and who are preparing for some technical examination related to JEE exams, and where thermodynamics, applied thermodynamics subject, if you are preparing, then you can definitely study from these are my expertise, and you can come to this YouTube channel at 8 p.m. and for 4 days I will be taking the classes related to thermodynamics, applied thermodynamics and fluid mechanics, which is very important I can say which are very important subject for your any examination. If you see any JEE level exam, these subjects are very important. If I talk about SSC JEE exam, they cover around 80%, more than 80% of weightage. So please everyone quickly join me for this session. Hello Anand Prateek. Good evening, welcome to a session. Good evening my friends, good evening, welcome to a session. And those who have joined me for this session, just take out some time to subscribe the YouTube channel if you have not done yet. And do not forget to press the bell icon. Also, my dear students, one more important thing that you should do if you have come in the session, please like the session and also share the session. So good evening everyone, welcome to the session, welcome to the Resultant JE YouTube channel. And this is my introduction where the students who have joined me for the first time and you are meeting me for the first time. My name is Vikas Sir and I am basically a mechanical engineering faculty. I have over 7+ years of teaching experience where I have mentored more than lakhs of students for different examinations like GATE, Engineering Services, SSC JEE and RRB JE and many other JEE level exams. Sir, is it useful for Tata Steel exam? Hi, Baipalli Naga Pravalika. Yes, if you are preparing for any technical examination, whether it is a Tata Steel or any JEE exams, where thermodynamics, applied thermodynamics, fluid mechanics, these subjects are these are my expertise subject. If they are present in the weightage, if you see the syllabus of your Tata Steel exam, if you find these subjects are mentioned, then definitely you can prepare from this session. So let's come to the question number 1. A fuel of cetane number 40 has the same ignition quality as a mixture of. If any fuel has cetane number 40, yes, come on, tell me everyone. Yes, please everyone answer this question. Just a second. Just a second. Yes, just a second. Okay. Just give me 1 second. Yeah. Yeah, I just needed few seconds. Yes. Yeah. This is the question number 1. A fuel of cetane number 40 has the same ignition quality as a mixture of. What is cetane number? First of all, we need to understand. Cetane number is basically, it is a number which will tell you the ignition quality of. This number will tell you the ignition quality and anti-knock quality. One thing is ignition quality, or you can also say anti-knock quality of diesel fuel. Diesel fuel should not anti-knock, sorry, so it should resist knocking, and that is basically determined by the value of cetane number. Now cetane number is basically determined with the help of two reference fuel. One is basically cetane Another is alpha methyl naphthalene. Although it is older reference fuel, okay, naphthalene, but now it is replaced with heptamethyl nonane. It is replaced with heptamethyl nonane. Earlier we used to have this alpha methyl naphthalene, but now we are replaced with this alpha methyl naphthalene with heptamethyl nonane. This is now replaced with this. Okay. So if we are having cetane number 40 cetane number means the cetane percentage, the percentage of cetane is 40% and 60% rest of that will be alpha methyl naphthalene. So the right answer will be option B, because if the cetane number, cetane number basically tells you exact percentage of, if cetane number is 40, that means cetane percentage is 40% and rest of the percentage will be of the other reference fuel. Okay. Some production class also needed, sir. Yes, Subhadeep, I will definitely ask my faculty who will be taking the production classes. I will ask, basically he is right now busy in taking the classes in GATE or GATE and ESE section. So that is why he is not able to take the classes, but I will definitely request him to take few classes for production and at least one class per week. Number of working strokes per minute for a 2-stroke cycle engine. Hi Ramjeevan, good evening, welcome to your session. Pushpendra, good evening. Number of working strokes per minute for a 2-stroke cycle engine are dash the speed of the engine in the RPM. So you must have studied at many places, you must have seen that if you do a comparison between 2-stroke and 4-stroke engine, so the major difference which lies between the 2-stroke and 4-stroke is the number of working stroke, the power stroke. Here one power stroke you get, here one power stroke or power basically is obtained in 2 revolution of the crankshaft. So for that, to obtain one power stroke, the crankshaft revolves 2 times, a complete 2 revolution. But here one power stroke you obtain, or basically you can say power is derived by just 1 revolution of the crankshaft. So when crankshaft will be having 1 revolution, then you will get 1 power stroke in the 2-stroke engine. Okay. Now, whenever we find this power, let's say we are finding the indicated power, or you are finding, especially when you are finding the indicated power, the formula is mean effective pressure into LANK by 60. So here for 4-stroke engine, because in 4-stroke engine you get the power stroke in 2 revolution. So in order to equate that with 2-stroke, you have to put n is equal to n by 2. Just the speed becomes half. Okay, if you have to find the power. But for 2-stroke, because in 2-stroke you are getting 1 power stroke in 1 revolution of the crankshaft, so speed will remain same. Okay, so the speed will be equal. It will not. But if you are talking about 4-stroke, if the same thing you are talking about 4-stroke, it will be half, 1/2. Okay. In order to eliminate the knocking in compression ignition engine, there should be, if you want to eliminate knocking in compression ignition, see compression ignition engine, we are talking basically diesel engine. We are talking about diesel engine. Okay. So diesel engine, if you want to eliminate the knocking in diesel engine, then what you should do? And for that, you need to reduce the delay period, because the main cause of knocking, or detonation in diesel engine is, or in CI engine is longer ignition delay. Because the ignition delay period is long, okay, because of that this knocking phenomena happens. So if you want to reduce this, you have to reduce the main cause of the knocking is longer ignition delay period. So we have to reduce it. We have to make it short. Apart from that, what you can do is you can have low self ignition temperature, early ignition, not late auto ignition, but early ignition, and high compression ratio. All the other factors are wrong. For which of the following engines a Prony brake is used to measure the brake power. A prony brake, what is prony brake? Prony brake is basically a type of dynamometer which is used to find the value of brake power. There are different types of dynamometer. It comes under the absorption type dynamometer, okay, absorption dynamometer, and it is used to find the brake power, okay. And but this one thing about the prony brake is it is used particularly for variable speed engine, okay. It is used to find the brake power for a variable speed engine. This is important for prony brake dynamometer. The mean effective pressure of an Otto cycle is the ratio between. Mean effective pressure of an Otto cycle, no, it's not only for Otto cycle, any cycle. If you talk about any cycle, the mean effective pressure is, for any cycle, mean effective pressure is equal to, it is equal to the net work obtained to the sept volume. This is the formula for mean effective pressure. So it is net work, ratio between the net work and the sept volume. So the right answer is option B for this question. Subhadeep, you are saying option D. Why D? The net work in the crankcase. No, it is not crankcase, it is sept volume. Okay, or displacement volume or stroke volume, you can also say that. The ratio of the volume of the charge admitted at NTP. NTP means, what is NTP? NTP stands for normal temperature and pressure. Normal temperature and pressure, which we basically, you know, it is, we take temperature, okay, no problem. Temperature is 15 and pressure is taken as 1 atmospheric pressure or 1 bar approximately. So under normal temperature pressure, the ratio of volume which is admitted at NTP to the sept volume of the piston, the ratio is called volumetric efficiency. Actually, volumetric efficiency is the ratio between the actual volume during suction. Now, whether that section take place at NTP condition, normal temperature pressure condition, or any other condition, but actual volume of air or charge which enters into the engine during suction to the sept volume, which is the maximum possible volume of engine. So that ratio is called volumetric efficiency. Next, in actual four-stroke diesel engine, the injection of the fuel inside the cylinder will cut off when the piston approaches. First of all, we need to understand the meaning of cut off. Cut off means fuel supply is closed. Fuel supply is cut off. Fuel supply is cut off means now the fuel will not be supplied, the heat addition will be closed. So if you see a diesel engine, if you practically see a diesel engine, so if you have seen the cycle of diesel engine, what happens in the diesel engine cycle? 1, 2, 3, 4. So basically, if this is top dead center and this is a bottom dead center position, then suction start at bottom dead center and completes at top dead center section start and close at bottom dead center in ideal condition. In actual condition, section start before top dead center and closes after bottom dead center. And this is the point of heat addition. The point of heat addition is this point where heat addition starts, and this is the point of cutoff. This is a cutoff point. Okay. In ideal condition, the cutoff take place at around top dead center, but in actual condition, the cutoff take place at after top dead center. Okay. So cutoff take place when the piston reaches after top dead center, the cutoff will take place. Okay. Thermostat is used in a water-cooled engine to maintain the. Why we use a thermostat in the water-cooled engine? Water-cooled engine, we will be using different devices, especially a radiator. You will be having a radiator. You will be having water jackets in the water-cooled engine. We'll be having pump. Okay, we'll be having a fan, and we'll be having thermostat. The main purpose of thermostat in the water-cooled engine is to maintain the temperature of the cooling water. So that is the purpose of thermostat. Thermostat is basically kind of a temperature operated switch which is set at a temperature, fixed temperature, right around 90 degrees Celsius. As soon as the temperature, the water which is basically used in the water cooled engine to absorb the heat of the engine. So to absorb the heat of the engine in the water cooled engine, we are using water. Okay, but for that the thermostat is set at a temperature of 90 degrees Celsius. As soon as the water will absorb this temperature and will reach at 90, this water will go to the radiator for cooling purpose. So it is a kind of a temperature operated switch, you can say. Okay, which of the following is not a type of wet sump lubrication? Lubrication system is of different types. There is a different types we can do the lubrication in the engine. Okay, so if you see the types of lubrication, we have mesh lubrication is one type of lubrication done in the engine. Okay, another is your wet sump lubrication. Okay, this is another type of classification of lubrication system in the engine. And next is your dry sump lubrication. These are the majorly three types of lubrication. Okay, but here they are asking about the types of wet sump lubrication. Now wet sump lubrication are further classified into three types: splash lubrication, splash and pressure lubrication, and only pressurized lubrication. Only pressurized lubrication. Okay, these are the three types of wet sump lubrication. Out of the options, this is not a wet sump lubrication. It comes under. It is another. It is a separate branch of lubrication. Okay, it does not come under the wet sump lubrication. Okay. The friction power of a single cylinder 4-stroke engine is estimated to be 25 kilowatt. If the mechanical efficiency is 75, then indicate power in kilowatt will be. See, if you see this question, in this question they are saying friction power is 25 kilowatt and the mechanical efficiency is 75. So indicate power, I have told you a direct formula for indicate power. It is friction power divided by 1 minus mechanical efficiency. Just use this formula, you will get the answer in few seconds. Okay, this is a shortcut to find this indicate power. If friction power and mechanical efficiency is given, just put this formula, friction power divided by 1 minus mechanical efficiency, you will get 100 kilowatt. Okay, this will be the indicate power. Clear? Are you all getting this value 100? Please try to solve this question carefully. 25 by 0.25, that will be 100 kilowatt of indicate power. How you are going to get this formula? If anyone is having a doubt how you get this formula, mechanical efficiency is equal to brake power by indicate power, and brake power is equal to indicate power minus friction power divided by indicate power. You can also write it as 1 minus friction power divided by indicate power mechanical efficiency, or we can say 1 minus mechanical efficiency is equal to friction power by indicate power. So indicate power you will get this. So ultimately, if you want to see, in the exam you have to save your time. In exam, your biggest weapon with you will be your time. Okay, if anyone is going to use that weapon wisely, then you can definitely win over the exam. But if you waste your time by calculating this formula, by obtaining this formula, then you are going to lose your time. So basically, you can directly remember this formula, that if friction power is given, mechanical efficiency given, apply this formula and just get the answer. Choose the correct answer from the following 4 options. There are 2 statements basically. First statement is, in case of water cooled engine, installation must be at the front of the vehicle. What installation? Engine installation. Okay, which installation? Engine installation should be at the front. If you are talking about the water cooled engine, like most of the cars, most of the automobiles or cars, if you see the water cooled engine, the engine installed at the front. Have you seen that? No, it is not a condition that it should be at the front. But in case of air cooled engine, definitely it is true that engine should be or must be at the front of the vehicle. Why? Because air cooled engine loses heat, or it gets cooled down with the help of the air. Okay, or with the help of convection heat transfer by air. Now, if the engine in the air cooled engine is installed in the front of the vehicle, then basically due to the dynamics of the engine, basically, have you understood the concept of fluid dynamics? So if you see that when you drive the motorcycle, or if you drive a scooty or air cooled engine, wherever we use air cooled engine like motorcycles, okay, scooters, scooties, okay, so wherever you use a air cooled engine, if the engine is installed at the front, then it will be a natural tendency for the air to take the heat of the engine. It will be the front of the vehicle is exposed to air, okay, so the heat transfer will be better. But in case of water cooled engine, there is not a problem of it's not mandatory to install the engine at the front. You can install engine at any place. You can install engine in the front, at the back, or at the middle of the vehicle. It is not a necessary condition. So first statement is incorrect. The first one is not correct, because in water cooled engine it is not mandatory to install the engine in the front, but for air cool it is mandatory. For power stroke of 2-stroke petrol engine, which of the following statement is correct? What is being said here is, in 2-stroke engine, there basically the whole operation of engine is performed in 2-stroke. What is the meaning of this? That means here we follow 2 strokes. That means we follow an upstroke and we follow a downstroke. In the downstroke, first let's talk about the upstroke. In the upstroke, we will be having the engine will be performing 2 operations simultaneously, suction and compression. Suction, compression together are performed during upstroke, and during the downstroke you will be having expansion, which is the power stroke, and exhaust. These operations are done together. Okay, so during the upstroke, what will happen? The inlet port. See, in 2-stroke engine will be having basically 3 types of port: inlet and transfer and exhaust. Try to understand this thing. These are the 3 types of port which we use. But if the cycle will start from the suction, here it is saying power stroke. If the cycle starts from the suction stroke, then firstly the inlet port will open, then transfer, then exhaust. But if the cycle starts from power, this is the power stroke. So if you're talking about the power stroke, so after you get power, what will happen? Exhaust will happen. So firstly, exhaust port will uncover. Uncover means open. So because open, close is generally said about the valves. For the port, we generally use the word uncover and covers. Okay. So basically, in case of a 2-stroke engine, if we start from the power stroke, then in power stroke, that means you are getting the power. That means expansion is happening. So after expansion, exhaust will happen. Exhaust will happen means exhaust port has to open. Uncover means open. And then after, what will open? Actually, ideally, after exhaust, again inlet port should open, then transfer port. But they have not given the inlet port, so we'll be using the transfer port. Okay. So the right answer will be option B. Okay. Clear to everyone? Next, lubricating oil is insufficient in case of mislubrication system when throttle is. Mislubrication system is basically this type of system of lubrication which is used mostly in the case of 2-stroke engine. It is used in 2-stroke engine only. 2-stroke engine only. So in the 2-stroke we use a mislubrication where during the suction in the engine, not just air and fuel, some part like 3 to 6% of oil is also sent during the suction in the engine. Okay, and this oil, what will happen? Air and fuel will get vaporized. Fuel basically get vaporized, and this vapor of fuel takes oil particles in suspended form for lubrication. So basically what will happen, this will get these particles of oil, they will be carried by the vapor of the fuel, and these vapor of the these oil particles will get stick means chipak jayenge, they will get stick to the surface of the part which need to be lubricated. This is called mislubrication, mostly used in two-stroke engine, but this mislubrication will be insufficient when throttle is fully closed, because the reason why we are saying fully closed and when throttle is fully closed, when we climb down the hill, then in two-stroke engine is used where? In the like motorcycle. So let's say we are using a bike, motorcycle or scooty, and we are coming down the hill. So while coming down the hill, most of the people, or it is a natural tendency that you will not have too much of acceleration, or some people basically close the engine, or they don't accelerate. Okay, basically the vehicle will not be, and when acceleration will not be there, then throttle valve will be almost closed. Throttle valve is basically connected with the accelerator pedal. It is connected with accelerator. So when throttle is closed, then lubricating oil will not be sufficient, and in that situation, mislubrication will fail. Stirling cycle consists of what process? So basically this is an air standard cycle. It also comes under the air standard cycle, which consists of two isothermal process and two isochoric process. Isochoric means constant volume. Okay, isochoric means constant volume. So these are the processes which take place. Now isothermal and two isochoric. The right answer is option D for this question. If we talk about Ericsson cycle, in Ericsson cycle you will be having two isobaric and two isothermal. Okay, so that cycle will be Ericsson cycle. This can also be asked in the exam, which cycle contains two isothermal and two isobaric. Which cycle contains two reversible adiabatic and two isothermal? That is Carnot cycle. Which cycle contains two reversible adiabatic and two reversible isochoric? This cycle will be, come on, tell me. This is your Otto cycle. Otto cycle will be having two reversible adiabatic and two reversible isochoric process. Clear? Which of the following statement is incorrect regarding assumptions of air standard cycle? Tell me. Which of the following is incorrect regarding the assumption of air standard cycle? So in air standard cycle we follow many assumptions, and few assumption is that perfect gas is used, okay, and constant specific heats. Perfect gas has constant specific heat. That is also important assumption, right? Constant specific heat of perfect gas. And chemical composition will be constant. Chemical composition will not vary, correct? Specific heat vary with temperature? No, does not vary. That will be constant. So this is a wrong statement. Okay, this is a wrong assumption. Heat loss will be negligible. Surrounding, there will be no heat transfer. There will be heat transfer inside the system, but not with the surrounding. And specific heat does not vary with temperature. Okay. In an air standard diesel cycle, the efficiency depends on. Diesel cycle efficiency depends on factors like the compression ratio, the adiabatic index, and the cutoff ratio. Okay, these are the factors on which efficiency of diesel cycle depends. Cutoff ratio, compression ratio, and gamma. That is ratio of specific heat is also called gamma. Option E is the right answer. Next, if cutoff ratio in air standard diesel dual cycle. Now we are talking about dual cycle. If in dual cycle, if you, first of all, what is cutoff ratio? Dual cycle, if I draw on pressure volume diagram, okay, it consists of 5 processes. Firstly, we do compression, then heat addition at constant volume, then constant pressure, then expansion, and then heat reaction at constant volume. So these are the 5 processes done in the case of dual cycle. And try to understand one thing. What is the meaning of cutoff ratio? Cutoff ratio is basically if when the constant pressure heat addition is done, in that condition, the ratio of the volume after heat addition to the volume before heat addition in constant pressure heat addition, that is called as cutoff ratio. If this cutoff ratio becomes 0, what is the meaning of this thing? Sorry, I'm saying 0. It is if it is become 1. Cutoff ratio becomes 1. Then what will happen? Then V4 will be equal to V3. That means we are saying that this constant, this cycle will not be like this. Cycle will be like this. And if this will be cycle, that after heat addition, constant volume, directly you are doing expansion, then this cycle will become what? This cycle will be Otto cycle. It will become Otto cycle. Clear? So this thing will not happen. This thing will not happen. This will become Otto cycle like this. Let me draw with another color. Cycle will follow like this. Then this will be the cycle. If cutoff ratio becomes 1. Next, an engine cylinder has clearance volume of 20 cc and compression ratio of 14. The mechanical and volumetric efficiency are also given. The actual volume of the charge in cc inducted per stroke. Cc means it is a unit of the volume, okay, centimeter cube, and actual volume of the charge. So when we say actual volume, we apply the formula of volumetric efficiency, which is the ratio of actual volume to the stepped volume. So that means no matter where they have given 2 types of efficiency, mechanical and volumetric, but will not be using the mechanical efficiency here. The mechanical efficiency will not be used. Here we'll be using the volumetric efficiency. And we have to get the value of actual volume. Stepped volume, we don't have the idea what's the stepped volume. So we have to do the calculation. Okay, this data will be used for finding the value of stepped volume. Compression ratio is equal to 1 plus stepped volume. 1 plus clearance volume by stepped volume. So from here you can just put the value 14 is equal to 1 plus clearance volume. Okay, 20 by stepped volume. Just put the value. Have I done the wrong calculation? Yes. Oh, what I'm done. Sorry. Little bit of confusion, sorry. Okay. So just solve this value, you will get the value of, from here you will get the value of stepped volume. Okay. And you will get 208 as the answer for actual volume. Okay. Next question is the pressure of the charge inducted through the inlet port inside the cylinder in the case of a 2-stroke engine is. You have to tell that during the suction inducted through the inlet port in case of a 2-stroke engine. First of all, in 2-stroke engine, when we say pressure of the charge inducted through the inlet port, what happens in the inlet port? In the inlet port, suction takes place. And when suction takes place, what is the meaning of suction? You are trying to, if anywhere suction takes place, what you are trying to do? We are trying to reduce the pressure inside. Pressure inside will be less than the atmospheric pressure when we will try to obtain the suction thing. When exhaust takes place, then what we are trying to do? Then in the case of the engine, inside the engine, the pressure will be greater than atmospheric pressure. Then only exhaust will take place. It's a very simple concept. Then when induction takes place, then pressure will be less than the atmospheric pressure inside the engine. Okay, inside the engine cylinder. Which of the following specification is generally measured in cubic centimeter? Cubic centimeter means centimeter cube. Short form is also called cc. But don't get misunderstood with this, that cc means cc basically means centimeter cube, right? But which of the following specification is measured? Measured means the unit. Obviously, the unit of centimeter cube will be unit of volume. Here also volume, here also volume, here also volume, volume. But which volume they are talking about? See, we generally don't measure the volume of the fuel inside the tank. That we don't measure. Volume of the exhaust gas, that we don't measure. Volume of the cooling water, we don't measure. These are all things we don't measure. But if you want to measure, they can be in centimeter cube, not a problem, right? That is just a unit. But actually, which is a measurable quantity? Which is the measurable quantity that we try to measure in the engine? We always measure the sept volume of the engine. Sept volume is that volume of the engine when the piston is at top dead center. That position is top, and when the piston can be at bottom dead center. Between these two positions, the piston will be having a reciprocating motion. Between these two positions, the volume which is covered, that volume is called as sept volume. Okay, and this is the measurable volume that we actually measure for the piston cylinder. Okay, apart from that, we also have one more volume which is clearance volume, but this is the sept volume, also called as, it is also called stroke volume, also called as cubic capacity of the engine. Okay, in a 4-stroke petrol engine during suction stroke, when we say 4-stroke petrol engine, then during suction, what enters in the engine? So in petrol engine, during suction, mixture of petrol and air will enter. When it is diesel engine, during diesel engine will be having air during suction. When it is 2-stroke petrol engine, then apart from the air and fuel, will also having some oil. Some oil will also enter the engine. Okay, so always remember this: 2-stroke petrol engine during suction, air and fuel with some oil. But if it is a 4-stroke petrol engine, only petrol and air will enter. For diesel engine, whether it is 4-stroke or 2-stroke, whether it is, generally it is 4-stroke diesel engine, only air will enter. A slow speed diesel engine theoretically operates on the principle of, why they are saying slow speed diesel engine? Why does the engine operates at high speed also? Yes, see, diesel engine has two operating cycles. One at slow speed diesel engine, due to high compression ratio of 16:20, we follow diesel cycle for diesel engine. And at high speed, the same diesel engine operates with which cycle? Compression ratio is 10:12. Then we follow the dual cycle for the engine. Okay, then we use dual cycle. Here they are talking about slow speed diesel engine. So for slow speed diesel engine, we'll be using diesel cycle, and diesel cycle heat addition is at constant pressure and heat rejection is at constant volume. Okay, heat addition constant pressure and heat rejection at constant volume, because we are talking about slow speed diesel engine cycle, and so it will be diesel cycle. Which of the following statement is false about the Otto cycle? False statement about the Otto cycle is, yes, those who have joined me for this session, also do not forget to take out few seconds to like the session and share the session also. Okay, it will just take seconds. And see, as a teacher, what is my purpose of asking you to like the session? See, liking the session will not give me any kind of marks. As a faculty, I don't get any marks, but it's just that when you are live in the session, it just get to know that how many students were present in the session. If there were 10 students, there should be at least 10 likes. If there were 20, there should be at least 20 likes, so that we are actually giving you something for free, because YouTube, we are providing you free classes. So at least we need some appreciation for that. That why we want the session to be liked. Why do we share? So that the students who are not informed, this is a new YouTube channel. We want it to be grow fast. We still don't have 1000 subscribers, and we want you to quickly subscribe the channel also. False about the auto cycle. It is saying compression ratio is more than diesel. Impossible. Compression ratio of the auto cycle compression ratio is 6 to 10. It is definitely less. Diesel cycle compression ratio is 16 to 20 or 22. So this is false. The maximum temperature in case of IC engine is obtained at, in any kind of engine, where will be the maximum temperature? Maximum temperature will be after heat addition. And just after heat addition, what happens? After heat addition, expansion will start. Or we can say, after heat addition, the temperature become maximum. In any engine, temperature is maximum temperature. Or start of the expansion, before expansion started or after heat addition is completed, so the temperature will be maximum. In any engine, whether you are talking about petrol engine or diesel engine, maximum temperature will be after heat addition and before expansion. A single cylinder 4-stroke engine operating at 80% of the mechanical efficiency develops a brake power of 60. The indicated and power loss due to friction are. Power loss due to friction is called friction power, and indicate power they are asking here. Brake power they have given this question. So we know the relation between these two powers. Indicate power minus brake power is equal to friction power. So if in this particular question brake power is already given, then we can say brake power is equal to indicate power minus friction power. If this is equal to 60, so you just have to fill in the blanks. Do fill in the blanks here. 40 minus 20 will be 20. This is wrong. 75 minus 20. No, wrong. 40 minus 20, 20. No, 75. Yes. So because after you subtract indicated and friction power, you should get 60. That is only possible in this option. So this question does not require your, you don't have to use your pen and calculate. You just have to use some brain, that if brake power is given and they have asked these two values, just subtract both the options, you will get the answer. Okay. Calculate the mean effective pressure of a 4-stroke engine with displacement volume of 0.05 meter cube and having net power of 1100 kilowatt. Speed is 1800 RPM. If we normally have to find the mean effective pressure, okay, in normal case, if you have to find the mean effective pressure, then you will be using this particular formula. And the formula is, it is equal to net work divided by stepped volume. Simple. Okay, you can use this formula. But here they have given this work is not work, it is power. It is given in kilowatt. Try to understand. If this is given in kilowatt, then stepped volume should not be kept in meter cube. It should be in meter cube per second. This thing, how many of you understood? That if the net work is in kilowatt, that means they have given power, then stepped volume should not be in meter cube, it should be in meter cube per second. So how you will find the stepped volume in meter cube per second? Stepped volume is given, displacement volume is already given meter cube. So it will be 0.05 meter cube into speed. Speed is given and divided by 2. Why 2? Because it is a 4-stroke engine. For 4-stroke, speed will become half into 60. Okay. If you just put these values, you will get the answer. It will be 1100 divided by 0.05 into 1800 divided by 2 into 60. Solve it, you will get the answer. Come on. Come on, everyone. So if you solve it, you will get the answer as option D, 1467 kilopascal. Are you all getting this value? Okay. The efficiency of the Otto cycle for the same compression ratio will be maximum when working fluid is same compression ratio. See, efficiency of the Otto cycle definitely depends on compression ratio. But there is one more factor on which efficiency depends, although it is kept constant, gamma. But if compression ratio is fixed, then the gamma will play the important role to tell for which of the following fluid efficiency of the Otto cycle will be highest. Where if you see, for air is generally diatomic state. Air is generally in the diatomic state where gamma is 1.4. Helium is a monatomic gas, gamma is 1.67, gamma 1.4 and gamma 1.3. So if you see helium gas, which is, if the compression ratio is fixed, the gas which is having the highest gamma will be having the maximum efficiency. Okay, so there is a graph also. I have shown you this graph in some earlier session between the efficiency of the Otto cycle and the compression ratio. If compression ratio is fixed, the gas which will be having gamma highest will be having the highest efficiency. Okay, so gamma highest will be for monatomic gas, helium. Next, in a diesel cycle, the cutoff takes place at 9% of the stroke volume. If the compression ratio is 16, what will be the expansion ratio? Cutoff take place at 9% of the stroke volume. The meaning of the statement is the cutoff is basically the cutoff volume. Cutoff is taking place in diesel cycle is cutoff volume, and that cutoff volume is cutoff volume, which is volume after heat addition minus volume before heat addition. This cutoff is at 9% of the stroke volume. Cutoff is at 9% of stroke volume. Stroke volume is volume before compression minus volume after compression. Okay, if you just solve this, you just divide it by this. Both sides you divide by V2. So what you will get? You will get cutoff ratio. This is called cutoff ratio minus 1 is equal to 0.09 of compression ratio minus 1. Firstly, you just solve this. Okay, you will get the cutoff ratio from here. Compression ratio is already given. So it will be 0.09 into 16 minus 1. So from here you will get cutoff ratio. And after you get cutoff ratio, you know cutoff ratio is equal to compression ratio by expansion ratio. Compression by expansion ratio. Okay, I have not written ratio, just add this here, ratio. So if you know this value, you can get the expansion ratio. Solve it, you will get 6.80. This value you have to get. Okay, firstly find cutoff ratio. If you get, then compression is already given, you will get the value of expansion ratio 6.80. Yeah, this is coming out to be 2.35. Okay, clear everyone? Next question, the minimum and maximum volume in an air standard Otto cycle are 100 and 800 cc. Thermal efficiency of the cycle approximately will be. See, Otto cycle efficiency you can only obtain if you know the value. If first of all you should know this formula. Okay, you all know this formula. Then what is being given in the question? Minimum and maximum volume of the engine. Do you know what is the minimum volume of the engine? Minimum volume is the volume after compression. Before compression, the volume is, this is V1, this is V2. This is a volume after compression. After compression, this volume is also called as clearance volume. Before compression, this volume is also the maximum volume. Okay. Now, compression ratio is equal to V1 by V2. It is given in this question, 800 and 100, you will get 8. You put the value, compression ratio as 8, gamma will be taken as 1.4 because it is 8 standard Otto cycle, gamma is 1.4. You will get the answer 57. Okay? Clear? An air standard Otto cycle having compression ratio of 8. It is compressed isentropically to a pressure of 148.3 bar and 690 Kelvin. If the pressure and temperature at the beginning of compression is 1 bar and 300 Kelvin, find the efficiency of the Otto cycle. See, efficiency of the Otto cycle you can find by using the formula. You can use this formula. We have written it so many times. Okay, first of all, you can use this formula. 1 minus 1 by compression ratio power gamma minus 1, but compression ratio is given here. You can use this formula, okay, and then also you will get the answer. You will get 56.5 or 57%. But if you don't know the compression ratio, if you want to use this data, then what is compression ratio? You get this formula 1 minus T1 by T2. 1 minus T1 is 300 by 690. Suppose you don't have calculator. Without calculator, you have to solve this question. So you know that T2 by T1 is equal to compression ratio power gamma minus 1. Okay. So 1 minus T1 by T2 is equal to 1 minus 1 by compression ratio power gamma minus 1. Just put the value, you will get the answer. Okay. In both the cases, either you use this formula, or you use this formula. Both the cases you will get the same answer. Okay. For constant maximum pressure and heat input, the air standard efficiency of the power cycle is of the order of. If we are saying the compression ratio is same and we are saying same heat input, so it is not same compression ratio. If not same compression ratio, then this will be the order of the efficiency. Okay, this will be the order of efficiency. If compression ratio is not same, then our diesel cycle will be having maximum compression ratio and diesel cycle will be having maximum efficiency. For same compression ratio, Otto will be having maximum efficiency. Sept volume of the engine may be written as. What is sept volume of the engine? So we have also drawn this diagram. This is top dead center. This is bottom dead center. Volume at top dead center is also called clearance volume. Volume bottom dead center is sum of clearance volume plus sept volume. And between these two is your sept volume. So this is total volume up to here is your volume at bottom dead center is sum of sept volume plus clearance volume, and here this volume is clearance volume. So if you have to find the sept volume, the sept volume will be equal to volume at bottom dead center minus volume at top dead center. So you will get the answer. Okay. For maximum specific output of an air standard Otto cycle, specific output means work output. We are talking about work output. For maximum work output of an Otto cycle, the temperature after compression and after expansion should be, this is called geometric mean. Okay, then temperature after compression, after expansion should be geometric mean of minimum and maximum temperature. See, in the case of Otto cycle, the minimum temperature is the temperature before compression. Okay. Okay. This is the maximum temperature. This is the minimum temperature. Okay. And these are the temperature after compression, after expansion. So condition for maximum work output of the Otto cycle is the temperature after compression expansion should become geometric mean. Okay, so option D will be the answer. If stroke volume of the engine is 300 and clearance volume is 20 cc, the compression ratio of the engine will be, compression ratio is equal to ratio of sept volume 1 plus sept volume by clearance volume, where sept volume is also the stroke volume, which is 300 and clearance volume is 20. You will solve it, you will get the answer 16. Okay, so correct answer will come out to be 16, compression ratio. Next, in an air-centered diesel cycle, at fixed compression ratio and fixed value of adiabatic index, diesel cycle efficiency depends on three factors we have discussed in this session: gamma, which is fixed, compression ratio, which is fixed. So after that, next factor on which diesel cycle efficiency depends is your cutoff ratio. So if gamma is fixed, if compression ratio is fixed, then if cutoff ratio is decreased, then diesel cycle efficiency will increase. So with cutoff ratio, it has just inverse relation. Efficiency has inverse relation. So thermal efficiency will decrease with increase in heat addition cutoff ratio. Okay. With increase in the heat addition cutoff ratio, thermal efficiency will decrease for diesel cycle. The pressure and temperature of air at the beginning of compression. See, this is the last question for today's session. Okay, so try to do it carefully. Okay. In case of an Otto cycle, the pressure and temperature at the beginning are given. The heat added per kg of air is also given. Compression ratio is 8. What will be the maximum temperature of the cycle? Gamma is 1.4. 8 ki power 0.4 is 2.3. Cv is also given. See, how can you find the maximum temperature of any cycle? Three, 4. Okay. Try to understand this question carefully. Temperature at the beginning is equal to 300 Kelvin. And heat added means heat supplied in the Otto cycle is Cv of T3 minus T2. This is the formula, because heat supplied is at constant volume, and heat supply at constant volume is equal to change in internal energy, right, which is equal to this. Cv is given, heat supplied is given in this question, which is 1436. Cv is 0.718. T3 you have to find. T2 you don't know what is T2. So कैसे find करेंगे? How to find the value of T2? So my dear, we also know one relation. T2 by T1 is equal to compression ratio की power gamma minus 1. Do you know this relation? Compression ratio is given 8. 8 की power 1.4 minus 1. 8 की power 0.4 is equal to 2.3 given in this question. So T2 will be equal to 2.3 into 300. Okay. From here you will get 690 Kelvin T2. And if you get the value of T2, you can just put T2 here, you will get T3. Okay. Are you all getting the answer? Okay, so just put the value 1436 is equal to 0.718 T3 minus 690. What value you are getting? So you will get 2690. 2690. Why are you getting option B as the answer? That is wrong. So that's all, my dear students. Those who want to prepare for RRB JE exam with Resultant, then you can join any of these batches. If you focus only on the CBT one first, then you can join our focus batch with this offer price, and this is the maximum price, MRP price. RRB JE CBT 2. If you want to prepare for technical exam of CBT 2, then you can join AIM batch. The cost is this. RRB JE CBT 1 CBT 2 combined. If you want to prepare for both CBT 1 CBT 2 combined, okay, don't want to pay fees firstly for CBT 1 then CBT 2, then you can directly buy this. Okay, this is a MRP price, this is the offer price, and you can download the Resultant app and you can call this number if you want to have any information regarding our courses. Then you can just call on this number or you can just mail us here. These are the courses right now, AIM batch and Mission batch. Okay, so that's all, my dear student. Do not forget to subscribe our channel, and also do not forget to like and share the session and press the bell icon. Thank you so much. Have a nice day. I'll see you tomorrow. Tomorrow we are going to practice questions on fluid mechanics. Tomorrow we are going to practice question on fluid mechanics. Okay, same time, 8 p.m. Thank you so much. Have a very nice day. We'll see you tomorrow, and take care. Thank you so much. Have a nice day. Thank you so much, everyone.